It is early in the morning and I just woke up. I am here in my cozy house and drink my hot morning coffee. For the winter, I would like to have something to check the temperature outside without the need to open the window. Sure, it will be cold, but how cold? Would be pretty nice to check the temperature without standing next to the window. I would like to have a comfortable way to check the temperature outside. Okay, let's be real here. It's more of a first world problem, but I like to tinker with hardware, so let's get into it. My setup should be as easy as possible. I cannot invest too much time into this. It is just a hobby project after all. Even though I want to build something reliable, I am going to use well-supported off-the-shelf components. This is my setup. An OLED display for the inside and a temperature sensor for the outside. Easy as that. I am not going to build the finished product yet. This is more of a proof of concept. I'm going to solder and optimize the setup later. In case you want to build the setup yourself, there is a written tutorial on bind.systems. Long story short, let's get into it. As temperature sensor, I am going to use a Bosch BMP 280 or BME 280, whatever the seller on eBay or AliExpress sends me. They often do not know what sensor they use since they pretty much look the same. They are technically different, but the difference does not matter for my temperature use case. They both can measure the temperature, they both use the same I2C commands, so it really does not matter. But if you're interested in the difference, there is a link in the description. For the inside, I need an OLED display. The SSD 1306 is an obvious choice. It is a well-supported OLED display, cheap and easy to purchase on eBay or AliExpress. With 0.96 inch, a little small though. Good enough for showing the temperature, I think. Let's see. I also need two microcontrollers for my setup. One for reading the temperature sensor data and the other one to show the temperature on the OLED display. I go with the ESP32. It is a well-supported microcontroller. It is also supported by the Arduino IDE. I would like to use the Arduino IDE as well. It reduces the amount of code I have to write. The Arduino IDE is also very beginner friendly, so it should be pretty easy for you to reproduce this setup. Link to the written tutorial is in the description. Arduino IDE with ESP32. Pretty solid setup. Since the two devices are physically separated, I need some kind of radio and wireless protocol. Otherwise, they cannot communicate with each other. We have Thread, LoRa, Zigbee, Wi-Fi, and Bluetooth. And these are only the popular choices. A lot of options to choose from. A lot. The ESP32 already has Bluetooth and Wi-Fi on board. And I want to keep it as simple as possible. Therefore, I am not going to use Thread, LoRa, or Zigbee for this. Bluetooth is pretty complicated to write code for. Wi-Fi, on the other hand, is straightforward to use. Therefore, Wi-Fi it is. There is still one problem. So much code to write. Even though my hardware setup is pretty clear at this point, I still need to write the code for the REST APIs. The API for the temperature sensor is pretty simple. Just call the root and it returns the temperature. Easy as that. The OLED display, on the other hand, is potentially more complicated. I would also like to use the same OLED display for other purposes. I already have a speed test app. I would like to use the display for the speed test results. Therefore, a generic API is a must. Writing such an API and library for it is very annoying and a lot of code. Fortunately, I have a solution for that. It is called the Web of Things. You probably never heard about it, so I give you a short wrap up. The Web of Things is a set of standards for the IoT. These standards are developed by the W3C. The W3C is basically a group of very competent engineers who work on bringing systems together. The aim for the Web of Things is to enable interoperability across IoT devices. The word is as hard to pronounce as it is to make reality in IoT. The situation in the IoT space is a real mess. Most devices are not able to communicate with each other out of the box. The W3C already successfully developed other standards such as HTML, CSS, or SVG. Therefore, the Web of Things is a pretty good bet to fix these issues. I guess you already use some of their standards in your daily work. At least I do. Not only does the Web of Things solve my issue with the API design, it also reduced the JavaScript code I have to write in order to connect the temperature sensor with the OLED device. But more on this later. I am not going to annoy you with a presentation of the Web of Things though. Let's build the hardware instead and use what in practice. So let's get into it. First, the temperature sensor. I already soldered the pins for the BME 280. I just need to connect the BME 280 to my ESP32. Easy. I also coded some little application for the Arduino IDE. It uses the BME 280 and the WebThings library. I have one function to read and update the data from the temperature sensor in the loop function. It updates the property affordance in the defined Web of Things thing description. So the device always returns the most recent temperature readings on the API endpoint. I just need to connect the ESP32 to my PC and flash the app. Done. Let's have a look how the things description looks like. We just have to call the endpoint /.wellknown/thing description for it. This path is defined in the Web of Things discovery specification. Here we have the endpoint for our temperature property. We can call the described HTTP endpoint and we get our temperature data. Let's do this. Easy as that. Next, the OLED display. The module was already soldered by the manufacturer. I just need to connect the module to my ESP32. I also coded some application for it. I use the Adafruit OLED display library and of course the WebThings library again for the REST API. The what thing description is a bit different for the OLED display though. Instead of property affordance, I need to use an action affordance. As the name suggests, it is used to define available actions on the device. In my case, a client can invoke the action to display some text on the OLED display. There is a function called doDisplay. It receives a JSON input from the REST API call. The input is a JSON object. It has a headline, subheadline, and a body. Easy as that. The function just needs to get registered in the WebThings library. The library handles the rest for me, parsing the request, creating the correct endpoints, etc. All done by the library. I don't need to bother with it. When I request the what thing description, I see the defined action affordance. It even describes the kind of input it requires. Other client libraries can understand this and handle this accordingly, but more on this later. Let's test if sending the text to the OLED display actually works. Okay, the REST endpoint returns the correct result. Let's have a look if our text is also displayed on the OLED display. Great, works as intended. I have my two devices. They both have a REST API and it works as I need it to. I still need to connect them though, in some way or another. I need to read the temperature sensor and send the data to the OLED display. As I said before, I want to reduce the amount of code I have to write. After all, less code means less maintenance. Lucky me, there is a great WAD package for Node-RED. If you're not familiar with Node-RED, Node-RED is basically a drag and drop tool to connect IoT devices. The Node-RED package uses a client library written in JavaScript. If you rather want to write the JavaScript code yourself, you should use that library. I wrote a tutorial for that library. Link is in the description. Let's get into the Node-RED flow. The flow is pretty straightforward. We trigger the flow by calling a REST API endpoint. The endpoint is available under our Node-RED root address /showTemperature. Later, I'm going to write a cron job which calls the endpoint every 5 minutes. So the display will show the temperature every 5 minutes for a duration of 30 seconds. The bottom part of the flow consumes the WattTD of the temperature sensor and requests the current temperature. In order to have the correct data format, I need to transform the response a bit. Otherwise, the display cannot work with it. The return of the function in display.json is the JSON object needed for my display. Easy as that. The upper part of the flow only consumes the WattTD of the display. I just need to join the upper and bottom part and call the display endpoint with the transformed temperature sensor data. Eventually, when I call the REST endpoint to start the flow, it should display the current temperature on the OLED display. Well, that works like a charm, even though there is still a lot to do in order to make this an actual product. But that is for another time and another video. If you want to create this setup for yourself, the link to the written tutorial is in the description. You know the drill. Subscribe, upvote the video, and follow our Twitter. Link is in the description. See you next time. Bye.